So as I promised you, from now on, we're just going to focus on some sample projects, right? We're going to practice what we've learned so far. So far, we've learned all the basics we need to be a good programmer. And to be a professional programmer, you have to master the basics, right? And how can you master the basics? By practicing them over and over again. So for a first example, I thought we can write the Python function to calculate the Fibonacci sequence, right? So if you already don't know what a Fibonacci sequence is, it's basically a sequence in which each number is the sum of the two preceding ones. Look at this. You have the first two terms, 0 and 1, right? And then from now on, everything is the sum of the previous two values. So 0 and 1 give you a 1. And then you have 1 and 1 that gives you a 2. And then you have 1 and 2 that gives you a 3. And then you have a 2 and 3 that gives you a 5. And then 3 and 5 gives you an 8, and so on. Let's get to it then. We want to write a function to does that for us, to calculate it for us, right? You remember how we define a function, def. And I'm just going to call it Fibonacci sequence, maybe. That's the name of the function. You can obviously give it any name that you want. And do you think we're going to need an input or not? I think we do, because as you can see, this sequence is infinite. It keeps going. So the user can ask you to calculate the, I don't know, like the second term or the 10th term of the sequence, right? So they have to give us number of terms that they want to calculate. By the way, when you put anything between, the period of three quotes, 3 double quotes here, and then 3 double quotes here, whatever comes in between, it's skipped. It's not executed. So it's like commented out, right? So let's get started. Another good practice here is to, whenever you want to write a code, try to comment it as much as you can, because it makes it readable for others and honestly for yourself too. Because you come back to your code after a while, you look at it and you're like, what happened? How did I do this? Why did I do this? So it helps you remember things. And to do that, you can just go this, and we're going to say define the first two terms, because these are fixed terms. They're not going to change. So term 1 is a 0, as you can see. And term 2, that's 1. And because we want to count n terms time, right? So we need a count for value. So count, we set it to 0, and then we can continue. The next thing we need to do is, let's comment it. Check if the number of terms is a valid number, right? What if someone says, calculate the Fibonacci sequence of term -5? That doesn't make any sense. So you need to be able to take care of that situation. So you go, if a number of terms, right, is less than or equal to 0, then print invalid. It has to be a positive integer, right? And then you can go elif number of terms equals 1. If they just want the first term, you just return the first term, right? And then you go print term 1, right? But if they want more than that, then what we do is that we go while count is less than number of terms, right? Then we want to do something. But something to notice here, we have already calculated or know the first two terms. We already know 0 and 1, and then we have 0 and 1 defined here. So we've calculated two terms. So here it cannot be n terms, it's n terms minus 2, right? Because we already do that. We've already done that. And yeah, we just want to calculate the remaining terms, right? That's why I put the minus 2 in here. And once we have that, we go new term. The one that we want to calculate is term 1 plus term 2, right? Easy. And then we need to do something. And I'm going to comment it here. And I'm going to say I update the old values. Now we have to update T1 and T2, right? It's easy. How do we do that? You already know. T1 equals T2. We assign the value of T2 to T1, right? And then you go T2. Now you want to give T2 a new value, which is the value of the new term. Be careful. If you do this first, then T2 has a new value. And then you do this, the new value of T2 is assigned to this. We don't want to do that. We want the old value of T2 to be assigned to T1 and the new calculated value be the new value of T2, right? We do this and then we go count plus equal 1. So we increment it so that we know that we've calculated one more term. And then we can go print new term, right? So this is our function, and we expect it to work. Let's see if it works or not. We have the function now, and now we call the function Fibonacci sequence of, I don't know, 8 terms, for example. Let's see what happens. Okay, as you can see here, it says if I calculate it, it's going to be 1, 2, 3, 4, 5, 1, 2, 3, 5, 8, and 13. So it says the 8th term is 13. Let's see if it's right or not. This is term 1, term 2, 3, 4, 5, 6, 7, 8. So that is in the 13. We can make it look cooler and say, just to make sure, just to show you that it doesn't matter the name of the variable, I'm just gonna go number of terms equals input. I'm gonna go how many terms do you want to calculate, right? And then I take this value, and instead of 8, I put it here. And now let's see what happens here. If I run it now, it says how many terms do you want to calculate? I'm going to go 10 terms. And it says error. This is not supported between instances of the string and integer. You remember we had that problem before. So I'm going to go, because like the input to this, like it receives it as a string, but you want it to be an integer number, right? So you have to call the integer function on it. So it gets the value, converts it to an integer. If this is too much for you, it's just like nesting two functions into each other, right? If it's too much, you can always like define a no variable and be like number of terms, integer value is int of this. But you can also do it in one line. It's easy enough. So let's see if that fixes the problem. It says how many terms? I have 10. And it says, cool, 1, 2, 3, 5, 8, 13, 21, 34, which is obviously here. And that is the 10th term of the calculation of this sequence, right? Interesting. The one thing that I want to talk about though, before finishing this video, is that instead of printing out values, you don't always have to print out functions. You can use something called return, right? It returns the value. It doesn't necessarily print it. It just returns it. So I can comment out this and be like, return T1 in here. And then here, instead of printing this value here, I can go return wing T, right? But pay attention. What happens after return is that when it runs the return, right? That's the end of the function. It jumps out. So if you keep the return in the while loop, right? After the first time it's executed, it doesn't go back up again. It just jumps out of the function. So you need to take it out of the while loop. And how do we do that? So it's just like taking the indents back, right? We are returning the value after the calculation is done, right? And then here, I'm just gonna go x equals that, and x now holds the return value by the function, right? And then I can go print x, right? This way, you skip all the intermediate numbers here, right? Like 1, 2, 3. You don't see any of these. You just see the end results, right? It's much easier. So if I run this, I expect to see, like for 10, I expect to see 34 again. Let's see what happens. How many terms you want to calculate? Why did it go up there? I want to calculate for 10 terms, and it says it is 34. Very cool. That's about it. And you can take a look at this code again, make sure that you fully understand what's happening here. And then also, I want you to play with the code. And by that, I mean, instead of having a while loop, let's see if you can make it work with a for loop. And let me know how it goes. Subscribe for more videos, and see you for the next practice. Thank you. Take care. Bye-bye.